Lecture in fluid mechanics and hydraulic machines. Now we will see one kind of problem, continuation of previous one. It was written mistakenly, like instead of 1000 I have mentioned 10,000. So I want to repeat the problem. Now the given data, they have given the data. So they have given the data. If 5 meter cube of a certain oil, if 5 meter cube of a certain oil weighs 40 kilonewtons. So they have given uh, volume equal to 5 meter cube, and at the same time weight equal to 40 kilonewton, also known as 40 into 1000 Newton. Now calculate the specific weight which they have mentioned, and specific mass density and specific gravity of the oil. So they are clearly mentioning it is an oil. Now coming to the fact, so specific weight is indicated by gamma and formula is W by V. So W is equal to 40 into 1000 by V is nothing but 5. So it is 8000 Newton per meter cube, because weight is in newtons and volume is in meter cube, Newton per meter cube. That is specific weight. This is first one. And second one, mass density. Mass density equal to gamma by G. So gamma equal to, already we got the value as 8000, and G is obviously we should know, that is 9.81. And after calculating 8000 by 9.81, it is 815.5 kg per square. That is kg per meter cube. So third one, specific gravity, that is indicated by S. So density of oil by density of water. Always try to remember it. Water means with a reference. So density of oil, just now we have calculated, that is 815.5, and it is divided by density of water is 1000. That is equal to 0.816. So no units for this. Okay, try to remember there is no units and not required units for this concept. So now we will see once again in a good way, because if some people might not understand my writing. So specific weight is equal to gamma equal to W by V. W is equal to 40,000 by 5. That is equal to 8000 Newton per meter cube, because weight is in newtons and volume is in meter cube. And rho is equal to gamma by G, that is 8000 by 9.81, that is 815.5 kg per meter cube. And the specific gravity, it may be G, so it may be S, or it may be SG, or it may be G. That is equal to rho oil by rho water equal to 815.5 by standard 1000, that is equal to 0.816. The similar way, try to attempt one more question. Volume they have given 3 meter cube and weight they have given 27 kilonewtons. So same thing, specific weight gamma equal to W by V. Okay, try this one. And mass density rho is equal to gamma by G. This also you people can try. And specific gravity S is equal to rho oil by rho water. So class assignment has been given. Just substitute the things, you will get. Nothing more than this. That is very easy and simple to tackle this kind of problems. Okay, let's solve it. Few people can pause the video and you can solve, otherwise I will solve. Weight equal to 27 by 3. That is equal to 9 Newton per meter cube. And again 9 divided by 9.81. That we will get as 0.917 kg per meter cube. Then again substitute here 0.917 by 1000. So it will be approximately 0.0009. So kind of problems you can do a practice session for the thing. So we'll see the next problem. Next problem, at a certain point, in a castrol oil, the shear stress is 0.216 Newton per meter square and the velocity gradient is 0.216 seconds inverse. If the mass density of a castor oil is 959.42 kg per meter cube, then find kinetic viscosity. So as earlier we discussed in the theory concept, dynamic viscosity as well as the kinetic viscosity. So this comes with the both are relevant only. So if you know dynamic viscosity, you can find kinetic viscosity. So like that. Okay, we will see at a certain point in a castor oil, the shear stress is 0.216 Newton per. Shear stress always represents tau is equal to 0.216 and the velocity gradient is also, velocity gradient means dv by dy, that is equal to 216. So first of all we should know the formula of the Newton's law of viscosity. Tau is equal to mu into dv by du. So from here tau is 0.216 mu into 0.216. So mu is equal to 1 Newton seconds per meter square. Now kinetic viscosity is equal to mu by rho. Already we know mu, that is equal to 1. Rho already they have given mass density of castor oil, that is 959.42. That is equal to 1.042 into 10 power minus 3 meter square per second. So here we can see fluid properties, the problem. From the equation of Newton's law of viscosity, it is observed that tau is equal to mu into dv by dy, where tau is equal to 0.216 and mu and 0.216. So mu is equal to 0.216 by 0.216, that is 1 Newton seconds per meter square. Now kinematic viscosity is equal to mu by rho. 1 by 959.42 equal to 1.042 into 10 power minus 3 meter square per second. Now we will see another problem. Two horizontal plates are placed 1.2 centimeter apart. The space between the plates being filled with oil of viscosity 14 poise. Calculate the shear stress in oil if upper plate is moving with a velocity of 2.5 meter per second. So first, every time you people need to note down the given data. Two horizontal plates are placed. The space between the place, that means distance between the plates, you can consider, so dy equal to, that means distance to 1.25 centimeters. Agree? Next, 14 poises, that is equal to viscosity is equal to 14 poise. Convert it into Newton seconds per meter square, that is equal to, is divided by 10. 14 by 10 Newton seconds per meter square, that is equal to 10 poise equal to 1 Newton seconds per meter square. So velocity of upper plate u is equal to 2.5 meters per second. So usually we know that tau is equal to mu into du by dy. Agree? This is a well known formula for us. Here the change in the velocity du equal to final velocity. So du means change in the velocity equal to final velocity minus initial velocity. That is equal to final velocity. How much they are given? 2.5 minus 0 equal to 2.5 meters per second. Hence, tau is equal to mu into du by dy. That is equal to 14 by 10 is mu into 2.5 by 0.0125. So tau is equal to 280 Newton per meter square. If we are going with the diagram, velocity is 2.5 and mu is equal to 14 poise. Distance is 1.25 centimeters. That's the thing. As simple as that, we can solve it. Now, it has been shown the distance between plate 1.25 centimeters equal to 0.0125, and where viscosity mu is equal to 14 poise, that is 14 by 10 Newton seconds per meter square. So u is equal to 2.5 meters per second, and we know that tau is equal to mu into du by dy. So here change in velocity is equal to final velocity minus initial velocity. Final velocity is 2.5, initial velocity is considered as 0. And hence tau is equal to mu into du by dy, that is 14 by 10 into 2.5 by 0.0125. So total shear stress tau is equal to 280 newtons per meter square. So this is 1.25, this is 2.5, this is oil is mu is equal to 14 poise. So this way we need to solve the problems related to fluid properties. Next concept, continuity equation. That means the continuity equation states that mass or volume cannot be created or destroyed in a fluid flow. That means you take an example from one point to other point. If the river flow is happening one point to the other point, so if assume there is no rainfall, assume there is no addition or removal of the water from that particular river stretch, whatever we are going to calculate from one point to other point, then this equation is valid to calculate to find continuity equation, maybe velocity at another location. So the amount of fluid entering a system must equal the amount of fluid leaving it. Assumptions, no accumulation. Understood? As I mentioned, if we are want to focus on a river at one stretch to other stretch, we should understand what is the this, we have to assume this is coming from one place to other place, and we should avoid rainfall, we should avoid addition or subtraction of some water. That means giving some water to through canals or for irrigation purpose, like kind of things. So continuity always, for example, something like this. This is a point A1 and we can expect some velocity V1. This is a point A2, we can expect some velocity V2. But we are taking this thing as the thing continuous. A1 V1 equal to A2 V2. I hope you people knows discharge Q is equal to A into V. So discharge means meter cube per second. Area is in meter square into velocity is in meters per second. So LHS equal to RHS. Now we can rewrite A1 V1 equal to A2 V2, also known as Q1 equal to Q2. Agree? So Q is equal to AV. So Q1 equal to Q2. Now A is nothing but cross-sectional area of the pipe or channel. V is velocity of the fluid. Subscripts 1 and 2 refers to two different points in the flow. We will see some kind of concept such that you people can understand more. As I mentioned, Q1 equal to Q2. Agree? A1 V1 equal to A2 V2. Shall we go with some kind of basic things? Area is equal to meter square. Velocity is equal to meter per second. And discharge equal to meter cube per second. Right? If you know these all things, we can able to find there is a thing called Okay, there is a thing called area is increasing. Velocity will increase or decrease, either increase or decrease. What should come here? If increase in area will give you what? That is what my question. So consider two different kinds of areas, A1 V1, A2 V2, already known as Q1 Q2. Now here the area is broad, here the area is narrow. So we have to know the relation. If increases in area, what is the velocity? That's what I am asking. So equation of continuity, that means conservation of mass, from that we can solve easily. One problem we will see related to that, and we will understand what is what. Now let us assume two sections. One is A, one is A, one is B. What is A and what is B? This is section A, this is section B. Here A1 V1 is different, here A2 V2 is different. A1 V1 is also known as Q1, A2 V2 is also known as Q1. Now at first section is width is 10 meters. Now second section width is 5 meters. Now depth is 2 meters. Depth is 3 meters. And velocity 1 is 1.5 meters per second. Well, velocity 2 they haven't given. As we know from the basic formula, A equal to width into depth. 10 into 2 equal to 20 meters square. Area equal to 5 into 3 equal to 15 meter square. Now we know that Q1 also known as A1 V1. Agree? So Q1 equal to what is A1? A1 is nothing but this one only. A2 is nothing but this one. A1 is 20 into velocity 1.5. So Q1 is equal to 30 meter cube per second. In the similar way, how to find V2? How to find V2? See, Q2 already equal to V2 A2. Agree or not? Okay. So we know A2, but we don't know Q2. But already there is a thing called Q1 equal to Q2. Now Q1 is equal to A2 V2 such that V2 equal to Q1 by A2. V2 equal to, what is Q1? 30. What is A2? 15. So now you will get 2 meters per second. Now you observe the velocity is at first one is 1.5 and velocity at second one is 2. That means here area is more. Here area is less. Here itself we can understand increases in area, decreases in velocity. From here, decreases in area, increases in velocity. Okay. This way it can be solved. That's what I told in previous session. Q1 equal to Q2, that is equal to A1 V1 equal to A2 V2. Now A is equal to meter square, V is equal to meters per second. So Q is equal to meter cube per second. So now increases in area. So increases in area, decreases in velocity. Increases in area, decreases in velocity. Decreases in area, increases in velocity. Okay. Like that you people need to remember continuity equation. A1 V1 equal to A2 V2. Q1 is also equal to Q2. That is what, if we are able to know the continuity equation concept, it is very easy to remember. The continuity equation states that mass or volume cannot be created or destroyed in a fluid flow. So the amount of fluid entering a system must equal the amount of fluid leaving it. Assumptions, assuming no accumulation. So where A1 V1 equal to A2 V2, where A is equal to cross-sectional area of the pipe or channel and V is the velocity of the fluid, and subscript C is A1 1 and 2 is nothing, 1 place to other place. That's what I have told, broad area with respect to the narrow area. So this is different concept. Today we have seen like if meter cube per second, 5 meters cube, they have given weight, volume is 40 kilonewtons. As simple as that, gamma is equal to W by V, 40,000 by 5, 8,000. Rho is equal to gamma by G, 8,000 by 9.81. And specific gravity is oil by water. Here also same thing, it is repeated. And here the just introduced about the shear stress, like kinetic viscosity, gamma, the shear stress equal to mu into du by dy, such that we got mu, that is dynamic viscosity. Then from dynamic viscosity we will get kinetic viscosity with respect to the rho. That is what I have mentioned here. And next one, we have some distance between plates is to 1.25, and viscosity already they have given dynamic viscosity, that is 14 pounds. It is converted to Newton seconds per meter square. And velocity of upper plate is 2.5 meters per second. So here hence the change in velocity is nothing but final velocity minus initial velocity. 2.5 minus 0, that is 2.5 meters per second. Hence tau is equal to mu into du by dy, that is 14 by 10 into 2.5 by 0.0125. So shear stress is 280 newtons per meter square. The continuity equation states that mass or volume cannot be created or destroyed in a fluid flow. So the amount of fluid entering a system must equal the amount of fluid leaving it. Assumptions, no assumptions. So A1 V1 equal to A2 V2 is also known as Q1 equal to Q2, and Q is nothing but AV. And we have seen area increases, velocity decreases, area decreases, velocity increases. And we have seen a problem, width equal to 10 meters and depth is equal to 2 meters, and width is equal to 5 meters, depth is equal to 3 meters. So velocity equal to 1.5 meters per meter per second, and velocity is equal to nothing. So here we can see area is 20 meters, and here area 1 is 20 meters, area 2 is 50 meters, and area and discharge Q1 equal to A1 V1, that is equal to Q is equal to 20 into 1.5, that is 30 meters per meter cube per second, and Q2 equal to A2 V2, that is equal to Q1 is equal to A2 V2, that is equal to Q2 equal to A2 V2, but we know that Q1 equal to Q2, that is equal to Q1 equal to A2 V2, so V2 is equal to Q1 by A2, that is equal to V2 is equal to 30 by 15, that is equal to 2 meters per second. So okay, that's what next class we will see the continuation of this thing. Thank you.